All right, so in this video, we're going to cover a part of section 3.3, which really gets into permutation testing via R, right? So we're looking at permutation tests. And as I mentioned in an earlier video, permutation tests will be our first technique for calculating p-values. And we illustrated this in that mice drug example, okay? So the next example is going to use one of the data sets called beer wings, which I showed you in a previous video for chapter 2. Okay. In the beer wings data set, we have 15 men and 15 women. And for each person, we recorded how many hot wings they ate and how many ounces of beer they drank. But for us in this example, we're just going to focus on how many hot wings they ate. All right. So we can imagine the beer wings data set being a vector of x1 through x30, with each x representing the number of hot wings that person 1 ate, person 2 ate, person 30 ate, all right? And the question that we're going to ask is, do men eat more hot wings than women, all right? We have a question, we have a data set. So our null hypothesis is that this notion of male versus female, this factor, has nothing to do with consumption of wings. So our null hypothesis is like, no, of course it doesn't. You have to convince me otherwise. So our null hypothesis is that the mean of the number of wings eaten by males or men is equal to the mean of the number of wings eaten by women, okay? The alternate hypothesis is that the mean of the number of hot wings eaten by men is greater than the mean of the number of hot wings eaten by women. Now, equivalently, we could have gathered the means on one side and had the mean of the men minus the mean of the women is equal to 0 versus mean of the men minus mean of the women is greater than 0, okay? All right, now, and I'll show you how we get this on R, but the beer wings data set links each person with whether they are a man or a woman, okay? And so in that data set, the mean of the men, the mean number of hot wings of the men was 14.53 wings, and the mean number of hot wings consumed by the women was 9.33. So that's going to be my X bar M, my X bar W, okay? And my test statistic is going to be the difference of X bar M with X bar W, okay? So we observe with the data set we're given that the difference is 14.53 minus 9.33, which is 5.2 wings. So we're saying, you look, it looks like men are eating 5.2 wings more than women on average, okay? Now, if gender is not a factor in the number of hot wings eaten, then this observed test statistic of 5.2 should not be that unusual to generate when I do a permutation test, okay? And if 5.2 happens to be a very unusual test statistic, well, maybe the alternative hypothesis is correct, okay? All right, shift you over. Well, hopefully you paused and copied. All right, so pause and copy, and I'm going to zip into R code at some stage here, but just sort of pause and copy what you got now. And the R code is in the chapter 3 R file that's on Canvas for you. So I think it says chapter 3 in class exercises. Okay, so here's the permutation testing process. Steps 1 through 4. Applied to the specific beer wings example, okay? So we're going to take the 30 people and we're simply going to randomly assign 15 of them to be in the men category, randomly. And the other 15 will default into the woman category, okay? So we're gonna permute who we consider to be in the M versus W category. Because remember, we're thinking to ourselves, this category doesn't influence the number of hot wings they eat. Okay, so we'll just randomly permute them. Now, each person is irrevocably tied to the number of hot wings they actually ate. We're just going to possibly flip whether they're in the M category or the W category. Okay. All right, so take 30 people, randomly assign 15 of them to be our new men, the other 15 to be our new women, and then calculate what's the average number of hot wings eaten by our men in this permutation minus the average number of hot wings eaten by the women in this new permutation, okay? So calculate that test statistic and record it somewhere, so store it in memory, okay? All right, I'm then going to repeat steps 1 and 2 many, 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 many times. 10 to the 5th minus 1, capital N equals 10 to the 5th minus 1 generally, or 10 to the 4th minus 1 times, okay? And each time I'm recording that test statistic. So at the end of this process, I'm going to have 10 to the 5th, what, 9,999 values of the test statistic, okay? And then I'm going to calculate the p-value. What percentage of those 9,999 test statistics are greater than or equal to the test statistic we observed of 5.2, okay? All right, one note here. I can't do all the permutations. There are 30 choose 15 ways of assigning 15 of these people to be M's and the others to be W's. That's about 10 to the 9th, between 10 to the 9th and 1.5 times 10 to the 9th different permutations. My laptop can't. Okay, so I'm just going to randomly do 10 to the 5th minus 1 of these. Okay, now I'm going to switch over to the R code and follow along and then try it on your own. So let me share our studio. Okay, so this is the top of chapter 3 file. And first off, I'm going to make sure that I've got the package selected. I need to have resample selected or it won't know what I mean by Beer Wings data set. So click on that. Cool. And now let's view that Beer Wings data set one more time. Okay, there it is. And if you note there, each person has an ID, and that ID will always be associated to the number of hot wings they ate and the amount of beer ounces they drank. We're only going to be messing around with this gender column, the F's and the M's. If you know there's 30 of these people, you could count 15 or 15. Okay? So that's what the data set looks like. And let's go back to my code. All right. Now, line 5 is asking for the mean of the number of hot wings eaten, and they want the mean divided by gender. Okay, so you don't have to memorize these codes, just remember you saw something like this and you can tweak it. So let me run that line, and it's hard to see, so let me expand that email. Okay, so if you look down here in the bottom left, you see that the women's average was 9.3 wings, the men's average was 14.53 wings. Cool, just like I said. I can state or store the observed value of 14.53 minus 9.33 as observed, and that's 5.2. So now R knows the observed test statistic. Okay, line 9. I'm going to simplify the data set for R. I'm going to just look at beer wings and the hot wings column. Okay, so I'm going to name this new data set hot wings, and it's defined to be, that's what those arrows mean. It's defined to be from the beer wings data set, the hot wings column. So I'm going to run that. All right. And now let's just talk through these lines before I evaluate them. Capital N tells me how many times I'm going to run through this procedure. So I'm going to make a loop here. And each time I run through the procedure, I need to store a test statistic. And I'm going to store it in a vector called result. Okay. So I'm going to define result to be a vector with n placeholders. Okay, so it's numeric. I'm going to store numbers in it, and it's got capital N placeholders. So that's where I'm going to store these test statistics as I run through each permutation. All right, so line 12 starts the loop for I in 1 up through capital N. Okay, so it's going to run through it capital N times. Line 14 is where we randomly select our new man, as it were. I'm going to create an index. So again, in line 14, index is the name, and I'm defining it. That's what that arrow dash means. I'm defining it to be take 30 and select 15 numbers from 1 to 30 randomly. Okay. So basically, take the numbers 1 through 30 and select 15 of them. That's who my men are. The others are women. Okay. And now in line 15, I'm going to use that index, that new naming of men versus women. So in my result vector, in slot I want to define what number I place in there. I'm going to take the mean of my hot wings data set, but only looking at the index numbers. the numbers I selected, the 15 numbers between 1 through 30 we selected, those are my men. So I'm going to take the mean of the number of hot wings those men ate. And then mean hot wings negative index. Negative index means the numbers not selected. So we selected 15 numbers between 1 and 30 to be our new men. Negative index is the rest of the numbers. Those are our new women. So take the mean of the hot wings eaten by the women, take the difference and record that in the result vector slot I. Run through that capital N times, okay? So I am going to highlight lines 10 through 16 and run them. And it's going to take a little bit of time. And so in the bottom left, you'll note that there's a little arrow pointing to the right. Once I run it, it's not going to be done running until we see another arrow appear. So there's no arrow, 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 there's no arrow. Could take a while. There's no arrow, there's no arrow, there's no arrow, there's an arrow. Okay, so that took, I don't know, what, 6 or 7 seconds, okay? But it's run through it, it's created this result vector. So now line 18, I'm going to look at the histogram of that result vector. So that's showing me all the differences between the average of the men and the average of the women. It looks like it goes from, I don't know, negative 5.5-ish to positive 5.5-ish. And here I'm going to throw in our observed test statistic. That was 5.2. And if you look, 5.2 is, it looks like an outlier in this thing, right? It's way on the edge. And now here's my p-value, line 21, and we'll talk about why I'm calculating it this way. But if you look, I'm asking for it to sum the number of entries in result that are greater than or equal to the observed, that was 5.2. I'm going to add 1 to that, and then I'm going to divide by capital N plus 1. So you should ask the question, why did he add 1 to the numerator and to the denominator? And that will be answered in a future video, but let's just calculate it. All right, so down here, I get 0 on the bottom left, I get 0.00064. Now, when you do it on your code, you might get a slightly different p-value because we're randomly selecting these permutations. We're randomly selecting 15 of these people to be men each time. And it might not be the same random choices for my simulation as for yours. So your p-values can differ, but they should all be somewhat ballpark. Okay, so let's go back to the video. All right, so here we go. So, all right, so R provided a p-value, and I guess one other time I did it was 0.0065. This time it was 0.00064. So that's the p-value, but that means the p-value is less than 0.1%, right? Like it's 0.064%, right? Well, that's pretty unlikely, okay? So, and that's my phone going. We'll just ignore it. So it's very unlikely that our observed test statistic of 5.2 simply occurred by chance. And the histogram was showing that as well. So we can conclude that there's statistically significant evidence supporting the hypothesis that men eat more wings than women. In other words, we're going to reject the null hypothesis and accept the alternate. Sorry about the phone.